Hello everyone. So let's do today's daily lead code challenge question. I am also looking at this question for the first time, so let's do this together. I'll set a timer of 30 minutes, and so I would want to solve this question within 30 minutes. If I don't, then I will look at the solution. So my 30 minutes timer starts now. Okay, let's see what's the question is. Given the integers 0, 1, low and high, we can construct a string by starting with an empty string and then at each step perform either of the following. Append the character, okay. And then at each step perform either of the following. Append the character 0 times, append the character 1 times. This can be performed any number of times. Okay. A good string is a string constructed by above process having a length between low and high inclusive. Return the number of different good strings that can be constructed satisfying these properties. Since the answer can be large, return it modulo 10 to the power 9 plus 7. So let's look at the example and maybe we might be clear. So output is 8. It means low, high. So one possible valid good string is 0, 1, 1. It can be constructed as follows. So from empty string, so if I add 0, then it will be 0, then 1, then 0, 1, 1. All binary strings from 0, 0, 0 to 1, 1, 1 are good strings in this example. Okay, so the answer is 8. That is why. Let me read the question again. So we can construct a string by starting with an empty string and then add it and then at each step perform either I can add 0 times or 1 times. Okay, so if I start from the empty string here, then I can add 0 1 time and I can add 1 times, right? So either it can be 0 and then it can be 0 1, or it can be 1 and it can be 1 0. I can do this can be performed any number of times, right? So since this can be performed any number of times, so I'm not sure, like, what does it mean when they say this can be performed any number of times? I can only perform it 1 time, like 0. I can only add to empty string 0 1 time only, right? Okay. Oh, I see. I think what they mean is, suppose 0 is equal to 2, then maybe I could have done 0 0 0 2 times and then 1 time and then 0 again 2 times and then 1 time, right? I think so. Suppose if 1 is equal to 2, then here you can see that 1 is added 2 times every time. Okay, so suppose if 0 is 3, then it could be, so if I start from the empty string, then it would be if I start from empty string, then if I add 0, then it would be 0 0 0, and then another time it would be, if I add 0 again, then 0 0 0. So yeah, so that is how we can form any strings. And the good string is a string that have a length between low and high inclusive, right? So if low is 3 and high is 3, then the length should be between 3 and 3. It means that the length should be 3. So if they say that the string length should be between the length 3 and 3, then it means that the length should be 3, exactly 3. Okay, so let's look at this example. 0 1 and 1, right? So if input is 3 and high is 3, then it would be if it is an empty string, it would be, I can add 0, I can add number 0 times, right? So it can be 0, or it can be 0 0, or it can be 0 0 0. But since we want exactly 3, so it can only be 0 0 0, or it can be 0 1 0, you know, like I'll just draw a tree here. So since the length should be 3, first of all it can either be 0 or 1. Then if we choose 0 first, then it would be either 0 or 1 again, and it would be 0 or 1 again, right? So until now we have formed 4 strings: 0 0 0 1 1 0 and 1 1. Now since we want length 3, so it would be 0 and 1 again, and 0 and 1 again, similarly, like so. These would be the possible numbers, right? Because at every point we have the decision either to choose 0 or 1. So this is one branch, right? 0 0 0 0. So in this branch, so if we are considering 0 0 0, how we got there? It means that for every character we are choosing 0. So first of all we choose 0. After choosing 0, we choose 0 again. After choosing second 0, we choose 0 again. So after choosing second 0, if we chose 1, then it would be 0 0 1, right? So that is the thing. And okay, so let's look at this example. Low is equal to 2, high is equal to 3, 0 is equal to 1. Okay, so low is equal to 2, high is equal to 3, 0 is equal to 1, and 1 is equal to 2. If we see this, then so it means that I can have either two digit string. This is string, right? I need to, two letter string or 3 letter string, right? Because the length should be between low and high. Then so I can add either 1 0 or I can add 2 1s. So it means that at every step there are two decisions. Then we can construct a string by starting with an empty string, and then at each step perform either of the following: append the character 0 times or append the character 1 times, right? So if I am starting with an empty string, then I have two decisions. Either I can add 1 time, 0 1 time, so I will add 0, or if I would go another way, then I would add 1 2 times, so it would be 1 1, right? So that is the case: 0 times and 1 1 times. The 0 times or add 1 1 times. So the case each here, it is 0 0. So if I am going this direction, then it is 0 0. If I am going this direction, then it is 0 1 1. If I am going this direction, then it is 1 1 0. Then if I am going this, then it is 1 1 1 1, right? So there are these many possibilities. So it means that this is the length of 2, length of 3, length of 3, and length of 4. So my brute force solution, what I'm thinking right now is, brute force kind of solution is, I can just go and branch like this, right? So at every step I would get a string, isn't it? I would get a string with some length. So what I do is, if I see that okay, the string length has not, when I reach here, then I can see that okay, the string length has not reached it is less than low, right? So I branch more. But if I see that the string length has reached it to its high, suppose here the high is 3, So it has reached to its high when I reach here, right? So 0 1 1. So I will not continue further. So that is my approach. That is what I'm thinking to do. So let's complete my approach here. So 0, now I am at 0, and then I'll look at 0. So I'll just, at every step I'll just continue adding the length. So at this step the length of the string is 1, at this step length of the string is 2. Since it is less than low, since it is less than high, so I will keep on adding 0 and 1 1. So now the length of the string is 3 and it is equal to high, so I'll not add anymore, right? So whenever I find a string that is, if found length less than, greater than low, it is inclusive, right? Greater than low, and so what I'll do is, if found, so at every level, at every point, check if length is greater than high, then just return, right? Then I will just stop looking forward. But if I find that the length is greater than or equal to low, so I'll just return here, right? So if I find that length is greater than or equal to low, then I will just add, then add it to total good string, right? So since low is 2, so at this step only I would have already added, so total good string would be 2 already at this point. When I reach here, then the total good string would be 3. When I reach here 2, then when I reach here, then it would be 3. So I'll not look further, and when I reach here, then it would be like that already, and from 0, so when I reach here, then it would be 0 1 1. So since it is 3, the length is 3, actually what I should do is, if length is equal to high, then also length is equal to high, then also add it to good string and then return. So yeah, and yeah, it means that, so this is my brute force solution using recursion. Okay, so what I was thinking is, maybe I could use memoization or something like that here. Maybe not, let's see. So first of all, I hope that you guys are clear about my approach here that I'm trying to take using this recursive kind of solution. So first of all, right, I'm just looking at every step, and then I'm just getting the length. I'm just adding the length at every step. Because like, what matters is the length, right? It doesn't matter if the number is 111 or 000 or anything like that. It just matters that it is just a matter of length. So it just means that since one each length of 1 and another branch length of 2, right? So to length I will add 1 here, and to length I will add 2 here. So add length of 1 here, add length of 2 here. So that's what I would do it at every step. I would add 1 here, and I would add 2 here. So this is what I'm adding. So at first it is 0, right? The length is 0. So since it is 0, then I will add plus 1, so the length will be 1. I will add plus 1, 1 plus 1, it will be 2 at this point. At this point it will be plus 1 plus 2. 0 plus 1 plus 2, what will it be? 3, right? So at this point the length will be 3, and at this point the length will be 3 again, and at this point the length will be 2 plus 2, 5, right? So it means that so yeah, I can see that I can use memoization here, because I can see that, like for example, if the high is very very large number, then I might keep on building along I might keep on building like then I might keep on building along, the tree will be so large. So at this point, if you see, it is 1 plus 1 plus 1 plus 1. What is 1, 1, 1, 1, 4, right? At this point, it is 4. So what it means that if I already know that at this point, what the value each actually, what is the length, I mean, because at this point it will be 1 plus 1 plus 1 plus 4, right? So it is the same, right? From 4 I am stepping something, and even at this point if you look at 1 plus 2 3 4, so at this point also it is the same, and at this point also it is the same, right? So at this point whatever I branch out, it is the same as whatever I branch out from this step, right? So if I know that at this point I mean, what I'm trying to say is I will branch out similarly, right, from this step and from this step, because the total length is 4. So I think that I can use memoization or something like that, but how? So actually I can also use bottom down dynamic programming, I'm thinking here. But let's think of top down dynamic programming first. Top down means just using recursion, using memoization. So first of all, I'll just think of how to use how to add memoization to my recursion. So I already thought of recursion, right? So let's think of how to add memoization to that. So so at this point I already have length is equal to 4, right? At this point, so if I know that I will have good strings from 4, right? Good string from length, if length is equal to, when I reach at length is equal to 4, then what will be the number of good strings? The number of good strings would be, like, suppose 10, right? Then I already know, okay, if I reach at length 4, then I know that is the number of good strings that I'll find. It's equal to 10, right? So it means that if I traverse this tree with this route, then I don't need to traverse tree with this route again, because up to here also the length is 4, and I don't need to do plus 1 plus 1 plus 2 plus 1 plus 2 again, because I already know that if I go this route, then the good strings length that I'll find is equal to 10, right? So yeah, actually I also want to do like this is hinting me towards bottom up programming also, right? So suppose if I say that if I know the length of 1 is equal to something, and suppose if I know that suppose if I know the length, if length is equal to 0 and 1, right? 1 and 2, right? So if I know good strings of length 1 is equal to something, and good string length 2 is equal to something, will I know everything? I'm just thinking about the bottom up here, because in the bottom up you should first of all find the value for the lowest one, for the base value. So what is the smallest value that I can find here? So this here I was trying to find bottom of DP here, like just trying to find first find the value for base. I was trying to, but I do not know like what I can find the base here. So first of all, like I was saying that I will do top down DP first here. So I'll just leave this, see it later, and now I'll look at top down DP. So top down, we're coming up to this, right? I was thinking until this. So good strings length is equal to 4 is equal to 10, right? So it means that will I be able to save this value? So 1 1 1 1 4. If I reach at 4, then if I know that that is the value, then okay, first of all, let me write the full recursion function here. Recursion algorithm, and then I'll think about top down DP. Okay, top down DP just means recursion with memoization. So in recursion algorithm, what I was doing is I was trying to find at every point, checking if length and add it to good string, right? So from 1 to 1 2 3 4, and then okay, suppose high is 4 only, then it means that then it shows that so whenever I reach the, so it means like the recursion here, the point is that I am just adding. By the way, I only have 7 minutes. So the point here is that I'm just adding the length at every point. So plus 1 1 2 3 4. So at every point I was just so suppose in this question, if low is equal to 1 and high is equal to 4, then first of all, okay, here only at this step only my result would have increased, right? Result would be 1 in at this point only 1, then at this point 2, 1 plus 1 2, then at this point 3, then at this point 4, right? So at this point it will be 4, at this point it will be 3, the value, and at this point it will be since I've already looked at this one, at this point it will be 5. So here I was just using result as a global variable, and I was adding to this result whenever total good string, I mean this is a total good string, okay? So I am adding to total good string whenever I find a good string, right? So that was my recursion value. Yeah, so here I'm using a global variable. So I think to memorize, can I just memorize like this? So from 1 like, will I be able to know? Okay, let's think. I can't believe that I only have 5 minutes left. Total is total good string. So I'm sleepy now. Anyway, so there, that was what I was thinking here. But I really like, is this done from 4? Suppose 1 2 3 4. Suppose like, okay, 1 and 2, from 2, or from, let's say, from 1. Like if I start from the length is equal to 1, then the function will be like this, right? Function find good string and length. So if I look at this, I think this is really simple, but I'm making it complex, so I just want to take a break of 5 seconds. I'm just looking to my left, to my right, up and bottom. Now let's get back. Okay, low is equal to high. So basically, if I know that, okay, if I know that I need to start from length is equal to suppose high is 20k. Suppose I know that I have to start from the length is equal to 10. Then what happens? If it is 10, then it would be since it is 1 and 2, length of 1 and 2, so it would be 1 and 2 again, right? So it will be 1 and 2 again, and it will be like some value again, 1 and 2 again, until I get to 20, right? So 1 and 2 again. So now this is 10, now it will be 11, here it will be 12. So suppose if it is at 18, then it will be 1 and 2 again. So if the length is at 18, now the value is here it is 19, and here it is 220. Right? And again, since this is equal to 19, so if I'm starting 19, then it will be 1 and 2. So the value will be, so from 19, it means that good string, total number of good string, it means that find good string for the length of 19, it will be equal to what? It will be equal to what? It will be equal to 19. I was just laughing, like, by listening to how I was saying what. Okay, I just paused my timer. Not paused, but I just like discarded my timer. And from find string good string 19, from find good string 19, so if I'm at length 19, then I can only find a good string that is equal to 19 plus 20, right? Maybe 2, because one is of length 19 and another is of length 20. So if I'm at 20, then it is 1 because it is 19, 20. If I'm at 19, then it is 2, right? Because find good string like 18, what is equal to find good string 18? It is equal to it is equal to 1 plus so if I'm looking here 18, then so at length 19 I can find 2 good strings, 19 plus 1. Length 20 I can only find 1. At length 18 I can find 119 and another one, right? So it is so it means that find good string 18, it is equal to find good string 19 plus find good string 20, right? Because from here I'm going to left, and if suppose if I already know what is the good string value from here, it is 19 too, right? So yeah, I think this is it. 19 plus 20. Actually I was trying to like look at recursion, but I think that this is just this has just become a dynamic programming like bottom up. But anyway, actually it is the same thing. So for find good string 18, I need to find like 19 plus 20, right? So and what about like 10? For finding good string 10, then it would be like 11 plus 12, right? If I know that okay what the value each, this one plus this one, 10 would be. Do I have to add one as well? Add one as well, right? Because 18 I should also consider 18 as well. So good string at 18 would be 118 only, one string of length 18 and one string of length 19. Find good string means that how many good strings can I make starting from this length. So what I mean is, when I am at length 18, then length 18 itself is a good string, right? So I should add 1, and then from 18 I can branch off to either length 19 or length 20, right? So if I know that how many good strings I can make starting from length 19, then I would know that, right? So I think this is the solution. 1 plus this one plus this one. So yeah, it means that dynamic programming bottom up approach is n is equal to 1 plus find good string n plus 0 plus find good string n plus 1. 0 and 1 is just this one. If I'm going to one direction, then I'm adding 1, right? If I'm going to another direction, I'm adding 2. So this is the thing here, and my base would be always I start from the high. Yeah, suppose if the high is 20, then from the 20, then it would always be it will always be what? It will always be 1 only. And then n, yeah, maybe I should first try bottom up coding and then do like and then relate to uh, bottom up and recursion. So okay, here I am actually bottom up I was thinking to see later, but that's what I ended doing. So yeah, find good string n is equal to high is 1, and what I should do next is, so after I find 20, then I need to find like what's the other base values, right? So if I know for 20, then I should know for find good string n is equal to high minus 0 is equal to something, and high minus 1 is equal to something, right? Or no? So if I know of 20, then I must know that so find good string. At last I need to find good string at 0, right? Because I want to know at length 0 what is it. So find good string at 0 would be equal to find good string at length 0 plus plus 1. Okay, like and I can only add 1 if this length, if n is greater than or equal to low. Plus find good string 0 plus find string good 1, right? So yeah, so g in 0 is 1 and this is 2, so this is that, and find good string 1 will be equal to also the same thing plus find good string 1 and 2. So here it would be 1 and 2, it would be 1 plus 1 yeah, it would be 1 plus 1 and find good string 1 plus 2 and 3. So find good string, like suppose it be 17, then it would be find good string like 18, 1 plus 18 plus 19 plus 19, and then 19 would be something. So actually this is the case. I guess actually like right now I'm trying to just be too like the most optimal. That is why I am rambling here and there. So let's do whatever I can first. So okay, I'll just, maybe I can just build a string, right, so of array, because here what I can see is my formula is such that I can just start from 0, and then for 0 I need 1 and 2, right? And for 1 I need 2 and 3 already, just like this tree. Actually this is all right. So for 0 I need the value of this one and this one, right? And for this value I need the value of this and this, because I'm starting from 0, and because I'm starting from the top here. That would what recursion do, right? Whenever I finish this, that would return this value, like 1 2 3 4. So I would get the value for 4 first, and then 3, and then 2, and then 1, and then at last 0, right? From top to down. Here also I'm doing the same thing, from top to down, but I need to go from bottom to up. I think that's what is the difference, right? From here I should not be doing from like this. I should be going from bottom to down. I should try to find a way to find a value to find a formula backwards, not this one, because this formula is only giving me the value 0 when I have 1 and 2. What am I saying? Okay, first let's just implement this and then see if I can do otherwise. So first I'll just first complete what solution I'm trying to suggest, because what I'm doing till now is I am just suggesting one solution and then jumping to another solution that I am having, that I get idea of, and then I'm going jumping to another solution that I get idea without completing my first solution, so okay. So there is a optimization maybe possibility. I'll just write that start from high and backward and go backwards to 0, right? Bottom to up. I think this is what this is why they say maybe. So let's see. Okay, so first of all I just want to go through this approach and see if I can find a solution or if I get stuck with it. So to go with this solution, right, what I need is, for n is equal to 0 I need 1 and 2. For 1 I need these values again. So it means that so before explaining this I can just say that okay, recursion is done, right? Because you can just I think recursion is easier, so I'm just trying to find a dynamic programming solution here. So if we see recursion, where is the recursion algorithm? I mean, anyway, recursion would be just I'd also written a function, isn't it, somewhere? Oh yeah, here. So in the recursion it would just save. In the recursion it would just use this function actually. Okay, and then save. So we would just save this find good string and then memorize it. I mean, saving means memorizing, so we would just save this and then use this, right? In recursion we could just use this function, because from 0 we are going to 1 and then 2, like this one. From 0 I'm going to 1 and then 2. From 1 I'll go to 2 and 3. So whenever the base value will be the recursion, the base value would be, if n is equal to high, then I would just return it, right? Then that is the value, so I just return it, whenever I find that value, then just return 1. If n is greater than high, then I would just return 0. And if n is, yeah, that's it. So this is where I would have returned. and I would just store this find good string value. So let me, I think, first implement this solution and then implement the bottom up or something approach. So first of all, find good string. So here what I'm trying to do is oh my god, indentation is like as if some child is doing this. Anyway, so find good string. Did I copy it? Yeah, I copied it, right? I did not delete it. N is equal to I. Find good string 0, add 1 is equal, add 1 if okay. I was just checking if this is above there. Okay, so first let's finish this. So first of all, I think that I'll just return find good string 0, right, at length 0. This would be my value. So if n is equal to high, then return 1. If n is less than greater than high, then I return 0. So for find string length is equal to find good string, this is actually length plus 0, and this is length plus 1, right? So this is the recursive function, and add 1 if n is greater than or equal to low, because that length is the value itself. So I would add 1. If n is greater than or equal to low, then add 1, otherwise 0. Right? Okay. That's it, I think. What should I do? Other thing. So first of all, this will be 0, this will be 0, and then since 0 would be less, so it would be just 0 would be equal to 1 plus 2. Okay, I think yeah, I should also use memoization here. Will this run? If length is equal to I could have just have used what did I do? Maximum call stack exceeded. If length equals to I, then return 1. What am I doing here? Like, it's been a long time since I have not coded here. It's saying that. So this is a basic recursion function. Okay, I think the time limit will exceed. Okay, time limit will exceed. So see, this is a basic recursive function, right? But I want to save it. So where to save it? Let array good string length array is equal to new array of length what? Of length I, maybe, and maybe I can just store good length array and length here. and just return that, right? So if I see that, if it is already there, then I just return that. So this is memoization. "17 only passed. Oh no, what did I do wrong?" Let's see. So if low is equal to low high 0 1, right? So if low is equal to high is equal to 0 and 1, okay? I think this gives me a lesson that first of all, just implement a solution, or just be sure that the solution that I'm thinking right now, the brute force solution, like even if it is brute force solution, that works. And only think of finding the optimal solution, because here what I did is I was just thinking, okay, the solution, I found the solution, I was trying to optimize more and more, I was trying to do a like bottom up and whatnot. But see, I thought that this solution would work, and this is not even optimal solution. So the solution I thought of did not work. Okay, why not? So length, if length equals to height, then return 1. If it is greater than height, then return 0. Otherwise, and length plus 0, length plus 1. Everything sounds good here. It's like 0 and then 0 1. If it is low 0, high is 200. Then if what to say, this is what 0 and this is 1, this is 0 and this is 1, then first of all it would be so here it would have been what am I doing here? If good string length array length, like what am I doing here? Good string array length, what 0, what would be in the beginning? It would be undefined, right? So if I just say that E is equal to new array and 3, and if I say 5, then it would be undefined. So this will be undefined until I assign it some value, right? Okay, so good string length array length is, if it for 0 it is equal to 10 plus 1, right? So I mean If the length is 0, then it would be equal to, because the length is 10 here and the length is 1 here, right? So at this point the length is 10 and at this point the length is 1. So whatever the value from 10 I get, that I must add from 1, isn't it? So from 1 also it would be it would be 10 and then 1. So here it would be, oh okay, it would be 10 and then 1. Actually the length would also increase, isn't it here? 0 and 1. So from here it would be 10 and 1, so it would be 10 plus 1 11, and here it would be 1 plus 1 2. Whatever the value from 11, it would be 11 plus 10, that is 21, and 11 plus 1, that is 12, right? Similarly the value would go on and on and on until, suppose if I get like 190, then it would have been, okay, this is 200 and this is 191. So it means that I've reached 200. So when I reach 200, then the when I reach 190, then it would be 190 is equal to 190 is equal to 190 plus, I mean 200 plus 191, right? So for 200 it would be 1, so it would be 1 plus whatever the value it brings. Yeah, it should have worked, then why didn't it not think? So I see the solution or what? 3311 and 2312. So is it the solution? Because I am too over the time. Create an array of size dp of size 1 plus I. Initialize dp 0 is equal to 1. Set answer is equal to 0. If n is greater than 0, then increment answer by count good strings. New int I plus 1. If int is greater than or equal to 1, then count is equal to count plus df is int minus 1, 0 comma 1. Create an array dp of size. My god. All 5 where low is equal to all 5 are good strings colored in green because 3 of the invalid strings are colored in red. Oh my god, 111 is why is 111 invalid? As its length is smaller than row? As it can't be made by multiple 11. What? Zero is equal to 1, 1 is equal to 2, right? So if 0 is equal to 1, 1 is equal to 2, then we can build an array of dp to record the number of good strings with each length. dpi be the number of good strings with length I. That's what I was trying to do, right? Like, why did I write? How did I become so messy? Like my mind was rambling here and there. Everything, like, did I delete everything? So how many good strings can I make starting from this length? A number of good strings with length I. This is a totally different thing. So dp0 is equal to 1 before filling the rest of dp as the empty string is the only one good string with length 0. Having a length between low and high. I just want to give up. Give up. Give up. I'm hungry. Hello. I'm hungry. Did you make any food?
Of course not.
Why not?
I was asking you if I should make food or not. You said yourself that you were gonna eat beaten rice and harikasa.
When did I say that? Like I said that too
No,
early.
you said that. You said don't take your words. Like I was like about to go and you said that you need to go.
No, I said that like make some. I said that like just this kida. Oh, return it modulo 10 to the power 9 plus 7. What? 10 to the power 9 plus 7? What is they saying? Ten to the power 9 plus 7. What does 10 to the power 9 plus 7 mean? What is the modulo operator here? Eighteen 36.
Zero झालं ना.
What? $26? How is 10 to the power 9 plus 7 26? What is bit? This is a bit operator. Like I'm really something. 20 days has passed. Low is 1000, high is 1000. Oh, time limit exceeded. Okay, it means that it is passing, but time limit got exceeded. Okay, I see. So my logic is right, but time limit got exceeded. Hmm. Okay. It's the same thing. How to go backwards? Like I look at the solution, but the solution like they are doing differently. So I was just trying to stick with my own solution. So if I have high, then how can I go backwards? Like how to do for n minus 1? Right? I can do. Maybe I can do like that, right? I know that. Um. Let's say this is empty, and I know that high it will be equal to um high will be equal to mm, first of all that field 0. I will be equal to 1, and n is equal to I minus 1 and minus. So it's basically like 0, and I mean n will be always equal to same thing, right? If n is greater than or equal to low, then it will be 1 or 0. plus n plus 0 plus n plus 1, right? And at last I will have length for n for 0, and I should move with percentage, right? Will this work? N minus minus. Oh. What? New array dot fill 0. What is happening? Why can't it fill? I can't use fill. Cannot read properties of undefined. Really? A is equal to new array 1. Oh, I think this is not the syntax. What? No, I thought that like I already gave up in the beginning. That's why I talked to you. Listen. I already gave up, and I thought that like I will not record this video. Just a second. I think I finished. Oh, I thought that I completed it. Oh my god. I think I'm missing some kind of. Okay, it worked finally. That's so funny that it worked, because I thought that I would stop recording this video. That's why I was talking to my husband. I my husband, my fiance actually. Okay, anyway, I'm not sure if I'm recording this video. Maybe I'm not sure if I'm uploading this video. Maybe I might upload, but in private, or maybe not. I don't know. Anyway, what I was thinking is like the solution that they are showing, it is completely different than my solution, than how I approached it. We can build an array dp to record. They are building array dp to record the number of strings with each length. So they are building the dp to record strings with each length, right? For number of good strings of length 5. But my dp approach it was different. It was like, how many good strings can I make starting from this length? That was my approach. Then we try to find the relation between each dpi with smaller problems. So the relation would be actually, guys, I'm really tired. This is my past bedtime, so you can just look at the solution by yourself, and I think that I should sign off here. Yeah, thank you so much. Bye.